Okay, we are back. More geometry with different looking nets. A net is a flat pattern that we can make from something that's three-dimensional if we take it apart on the edges. And some of you might want to do that if you have an empty box around. See if you can cut it along the edges or break it apart along the edges. See if you can make it into a flat pattern like you see here. So we need to decide with this challenge. Is it a pyramid or a prism? A pyramid is something like a box that has a top and a bottom, and it has sides that are flat lateral surfaces. Like a dice would be an example of a cube. That's a three-dimensional shape. This here is a prism, because it would have the top and the bottom would be both flat, and it has faces that go all the way around. And if you take a look at this, we have, let's see, 6 faces. The faces are these flat things, these boxes that I have over here, these squares. And if I cut it around the edge, all the way around the edge, I could fold it up and I could make it into a cube. The shape of the base here would be a square. And are the faces the same shape? Well, I'm going to have to go with yes, because they're all shaped like squares. This one here, if I can imagine cutting this out around the edge and folding it up on the lines that were not cut, that to me would make what we call a pyramid. And we might think of the pyramids that we have heard about or seen pictures of in Egypt. And a pyramid has only one base, and then the rest of the faces come up to a point or an apex at the top. The number of faces here, we have 1, 2, 3, 4, 5. So only 5 faces. The shape of the base, this is the base here, and I'm going to highlight that with my trusty yellow highlighter. This is the base. And the base could be considered as a square. If we rotate it a little bit, it's easier to see that it's a square. Now I'm going to go ahead and put it back this way so that I can have my paper easier to write on. So the shape of my base is square. Are all the faces the same shape? No, they are not. This next one here is a pyramid or a prism. Well, if I can imagine this cut up again around this outside edge, I think that I can picture this being a long, skinny rectangle. And so it's going to have no points to it except on the corners, and it's going to have a bunch of those, but it's not going to look like a pyramid. So I'm going to call it a prism. In fact, I can call this a rectangular prism. Number of faces, 1, 2, 3, 4, 5, and 6. 6. Now the shape of the base is kind of complicated, but because I called this a rectangular prism, I am going to make the decision that when I put it together, I would fold it up so that it would lay on its long rectangular base there, okay? And so I'm going to say that the shape of the base is a rectangle. Are all the faces the same shape? No, they are not. 2 are square and 4 are rectangles. And I know you're probably wondering where the base is up here, and the base up here doesn't really matter, so I'm just going to pick one of these squares, because you know that when I shake a dice, depends on what number lands on the floor or the tabletop. So now we've got all of our bases so far highlighted. Is this a pyramid or a prism? Well, again, this is going to, if I think about cutting it out on all these edges and folding it up, I can make a pyramid because it's going to come to a point. It's going to be a little bit different pyramid than the ones that we've seen pictures of in Egypt, but it is going to be a pyramid because it's going to have an apex, or all of those are going to come to a nice, neat point at the very top. Number of faces here, 3, 4, 5, 6, and 7. The shape of the base, I've got 1, 2, 3, 4, 5, 6. So that's hexagon. Are they all the same shape? No. So these are all flat patterns that we could enlarge and cut out, fold up, and make either pyramids or prisms from. And I just realized I didn't show you what I was doing for that last one. So let's take a quick look at that again. 7 faces, 6 sides to the base, so it's a hexagon. They're not the same shape, and it's a pyramid. Sorry about that, boys and girls. And now we have a problem. Which nets will fold up to make a complete or closed prism? If a net will not form a prism, explain why not. All right, so let's start with this one. This one reminds me of the first net that we have on the previous page. But if I fold this up, it's not going to be closed. And that's because I don't have a square on the opposite side. This would make the 4 sides around. This would make the bottom or the base, and then this would overlap. So this would overlap one of the other sides, and this I'm going to call the base. Letter B, this is kind of cool. This is a triangular prism. And the reason I'm highlighting the triangle is because a prism that has the name triangular prism has a triangular base. And we could call either one of these the base. So this is yes. And it's a triangular prism. Okay. This one down here is no. And the thing that it is missing is the opposite base. And like over here, we've got 2 triangles that would be opposite each other if we folded that all up. Well, here I only have 1 pentagon, and I need another pentagon. So it's no, missing another pentagon. Oops, pentagon shaped face. And another word for face is side. And then this last one up here, I'm going to go ahead. It's another rectangular prism, and that's our base. Now, if we were going to say yes, these 2 things here would have to match. But this does not match. This would need to be longer. And I'm going to just estimate it would have to be about that long in order for it to match, because it needs to match this one. Those 2 need to match. So I would say no. This face, remember we call it a side, is too short. And there we go. More practice with surface area and nets and volume tomorrow.